Okay, welcome to another webinar or presentation, short presentation. Today we'll be talking or extending conversation in terms of decentralized identity, talking about the basic idea and what are the challenges that are out there with decentralized identity. So, just to start, we're gonna take an example of how do this new financial institutions, at least the 21st century financial institutions, are opening financial accounts online. So these are new financial institutions, banks that are providing branchless kind of accounts in which you don't have to go to a branch of the bank, for example, to open a bank account. You can do this online or from your phone. So we'll start with this example, and then you'll see the challenges that are out there, and then we'll continue with those challenges and how they can be potentially solved. So the first thing when you encounter these type of situation, when you go to a financial institution online and you want to open up an account, the first thing they're going to ask you is, we want to validate your identity, and to do this, just send us a selfie or a video of yourself holding some kind of credential, in this case legacy credentials that have been issued to you, so we can then verify that those are correct. So a lot of financial institutions are doing this at the moment to open these bank accounts, and they go through the stringent compliance procedures in place. This is just another way of doing it. So once you do that, like in this example, the lady holds up the ID, and as you can see in the picture is she's holding or keeping her fingers on top of certain identifiers of your ID, right? So obviously this is not going to work. So they're going to say, oh, well, can you send us another picture? So she goes ahead and tries again, and obviously now she is not covering those identifiers, but she's covering her face. Which means that now, well, obviously this is not going to work either because we can't see your face. Then finally she does it again, and in this scenario, it works because now I can see her face, I can see the identifiers on the ID, looking at the identity of the individual, I can see that they match, and I can verify and open an account for her. Or like this, where fraud has been committed. So as you can see, deepfake is one example of software in which it can in a very interesting way, they can change and manipulate. Using software, you can manipulate any videos or selfies to suit whatever is required. So obviously in this case, the account has been opened fraudulently. Right, so obviously big challenge here in this case. So let's just talk through the basic idea of how this works and what the solution is. In this case, decentralized identity. So what you have is you have a holder, right? So that's the same that lady right there, the holder of the identity. They have the identity, and what happens is that they're going to initiate a conversation or some kind of communication with an issuer. And obviously this is all online, so there's no physical connectivity in this case. So the issuer and the holder have to establish some kind of cryptographic safe, some kind of connection between them, right? So what the first step is that the holder creates what they call a public-private key combination. We've talked about this in the previous sessions, but the holder here has a secret key that a holder only controls, and she's the only one, she or her is the only one that has this secret key or private key, if you want to call it. And then she also has a public key. Public key is something that you give to every entity out there. You give to every individual that you meet. It's your public key. It's for the public. You can make as many copies as you want. You give them to whoever you need to give them to. So that's the first step. So the issuer takes that public key that's from the holder because it's public, gets that public key, and with that public key, they create an encrypted version of her license, right? So it's those zeros and ones up here. So it creates this digital ID that represents the driver's license because they're issuing it, right? And only this holder has possession. So they actually issue that back to them using that public key, right? But the only person that can decrypt this message that they just digitized is that holder with the private key. Not even the issuer is able to control this ID. So now this ID belongs to the holder, right? So the holder has complete control of that data, complete control of the ID, so she or her can then move on with her life and start issuing or connecting to other individuals using this identity. So now, how does this work, right? So let's open a bank account doing this scenario, right? So now we have the holder with that secret key, and she has an encrypted version of her issued license that was done by the government. Now she goes to a bank, right? So the bank says, okay, fine, I'm going to open an account, but I need some information from you. I need your name, I need if you're 18 and over, and I need also if you're a resident of the United States to be able to open a bank account. So the holder then provides, yes, I am Alice, I'm over 18, and I'm a US resident. I'm going to use this issued encrypted ID that I got from the government, and I'm going to give you only these three pieces of information. And that is being used or being done through the use of the secret key. I send that information to the bank. The bank is able to corroborate this by looking at a blockchain, for example. One of the solutions that we're talking about is Decentralized, the use of a blockchain, a decentralized database. That the bank can then check the signature of that encrypted message and see if it was really Alice that signs it, because she's the only one in the world that has the secret key that's able to perform this type of task. So the bank then says, perfect, I'm going to make a loan. You're over 18, we can go into a contract. You're a resident as well, so we can do this contract in the United States, and you are actually Alice. So the loan is given to you. Transaction. So much better than using the traditional way or the legacy way in which you have to send pictures and photos that could be forged, etc., etc. This is mathematically proven. That cannot be, I mean, if this type of encryption gets broken, we have other problems in the world, because the whole world revolves around these protocols and standards. So let's just go through some of the goals of decentralized identity. First one is, actually two of them here. Improve your user experience credentials, that's the first thing. Reduce fraud, so those two things. So obviously we have improved the user experience, because now they don't have to stand in front of a camera and take a video and take a picture and hold the credential the wrong way. They don't have to do that. Reduces fraud, because as we saw, this is mathematically proven, so you cannot really go out there and hack or trying to fool and manipulate the video or the picture. You also empower the users to manage their own data, and the way this works is this is going beyond identity. So identity documents, it's beyond that. Why is it beyond that? Because when you encrypt IDs, you're also encrypting, say for example, transactions between the bank and you. You can use those keys to do exactly the same thing. It could be the keys that can encrypt a transfer of cryptocurrency, for example, between individuals. In the case of Bitcoin, same thing. Another thing that another goal that it provides is it provides credentials to disenfranchised and stateless persons. And what this basically means is that there's a lot of people out there that don't have or live in governments that have very poor managements of identity and credentials. It's corrupt. They don't have the financial means to maintain it. They could have gone through wars and economic troubles that countries can't provide good, sound identity like we have in the United States, in Europe, and in Asia. Australia has very good. So there's certain situations in which there's some people that don't have an ID, and they're actually stateless, because there's no state that can prove that they are a resident of a specific country, for example, or a citizen of a country. So this provides, allows organizations like that actually provide services or humanitarian services or humanitarian aid to countries they can use these type of decentralized systems to issue their own, because they know the people that are there. They're making the inventories, they're making the connections with those people, and they're actually giving them, they could give them some type of identity, that they belong to an organization or a region that the government can't provide. So that's another goal of decentralized identity. And finally, the reduction of personal identifiable information, or the proliferation of this information. It reduces the enterprise liability. And what this means is that companies and enterprises and institutions have the responsibility at the moment to hold these silos of data, of personal data. They're not their data, it's the individuals or the users' data. And they have different jurisdictions, different regions that they belong to. They have to abide by certain regulations. You know, how long do you keep that data? If the user decides to remove the data, you have to guarantee that you can remove. So you have to have all these infrastructure just to maintain that and provide that regulation satisfaction to the regulators, or keep that standard going. So it's a very big headache and liability for these institutions. So they would love to have this information be in the power and the hands of the user themselves. So they take over. So the decentralization of this data means that they don't have to hold that data anymore. They don't have to protect it. They don't have to use the resources to maintain and manage these and keep compliance on this data, et cetera, et cetera. So that's another goal that's very important for decentralized identity. But all of these things come with challenges, and to realize this decentralized identity. And the first challenge is three of these. The first challenge is credential issuance. So basically what that means is, okay, which are the issuers that are actually digitizing, in this example, licenses or some kind of identification, and creating encrypted information about this, about holders, and giving it to holders? There's none. There's not that. Maybe some institutions that might be doing this. Maybe some countries are planning on doing it, but at the moment there's just no issuers out there doing these things. They're doing the legacy way. They're printing their IDs. They're issuing them their certificates, etc., and then providing that to the user. But it's the legacy system. It's not the encrypted version of what we're talking about here, using cryptography. So the challenge, this credential issuance challenge, is the reason it exists is because you have this decentralized identity ecosystem. This is the infrastructure, the platform that's going to be doing this. Well, they need to receive issue from issuers, and if there's no issuers that are issuing decentralized identity, cryptographic identity, they cannot provide, they cannot provide that to the users, right? Because you don't have you don't have the issuers, and then the issuers are then looking for, okay, which platform am I going to issue this on? Is it going to be in a Microsoft platform? Is it going to be in a protocol standard that we have, which is a protocol standard? We don't have a protocol standard. There's a lot of them out there being worked on, but there's not one right now. So the issuers are saying, okay, well, we're waiting for the decentralized identity ecosystem, but there's none. And the decentralized ecosystems are waiting we need issuers to give us identity information, right? So it's like a chicken and an egg. If you can see that there's a chicken and there's an egg, which comes first, the chicken or the egg? So we're in this bootstrap dilemma at the moment. So this is a very big challenge to overcome, credential management. The second challenge for decentralized identity is key management. Users are just not good at managing their own private keys. They will lose them. They forget them. One big example is Bitcoin itself. We've got, like this headline says, 4 million Bitcoins lost forever, because people lose their private keys. If your hard drive goes into a dump or goes into the water in the ocean, and your laptop breaks, or you just misplace, or somebody takes your Bitcoins. The management of keys, especially in the case of Bitcoin, we're talking about money, But identity might even be a worst case scenario because people have nightmares by losing their credentials to Facebook, for example, hackers that steal their passwords and break into their account. Well, this would be the same idea. If they can break into that secret key, they take your identity. So, big challenge here. How do you manage keys? How do you prevent these things from happening? And we have an idea of how to do this because we've seen it with Facebook and we've seen it with Google and we've seen it with other places where you can call these institutions and tell them, hey, can you reset my password? And I can prove who I am and go back to the legacy system to prove who they are. In the case of Bitcoins, you don't have such a thing, privilege. That's why I mentioned this as this headline, right? So key management is a very big challenge to the realization of decentralized identity. Another aspect of key management is that we have this centralized financial system. This is just taking the example of Bitcoin. But we've decided to decentralize, the financial system because we said we want to be our own bank. We want to take control of our own value, money that we have. So we have these individuals holding Bitcoins like you see in the picture. So each one of these Bitcoin symbolizes a person or an entity that's holding Bitcoins, right? And they realize that managing these keys is a problem, especially when your value becomes bigger and bigger and bigger and you decide, you know what, I cannot handle losing my keys when I have so much wealth, right? So I'm gonna include a third party, and this is where Coinbase comes around. Coinbase is one of the biggest exchanges out there. Well, actually what they do is they become banks, so they keep your keys for you. So if you ever have a problem, you just point to Coinbase and Coinbase will say, oh, we know who you are because you can present your legacy identity, for example, and be able to give you access to your coins again, right? So basically we've re-centralized the whole aspect of decentralized the financial system. So we went from here over to re-centralize again. So again, a big challenge in terms of key management. The last challenge that we want to talk about today is the challenge of Sybil-resistance. What does this mean? Sybil-resistant means you normally have one identity. That's your identity. That's who you are, right? But what's going to stop you or anybody else that has your private key, for example, recreate a new identity, right? Or create a brand new key pair and create a new identity with forged documents, for example. And again and again, and you can keep going down the path and realizing that you're creating multiple identities. So what's going to stop this from happening? We see it with people. In the case of Facebook or Twitter, you're able to have one identity because obviously there's a third party that manages that identity, right? So they can prove, well, you're not able to create another identity because you already have one in our databases. So they control that centralized aspect, that third party, to say that person cannot create two identities, right? So again, in a decentralized identity, you have to be able to prevent this from happening. So this is a very easy thing to do or to solve, basically. And the way you solve this is without privacy. So if you don't care if Facebook knows who you are, if you don't care if Twitter knows who you are, if you don't care if Google knows who you are, so then there's going to be one identity because you can trust Google, you can trust Facebook, you can trust Twitter, saying this is who I am, and you can go to them and they'll vet with that because I have given my privacy to them so that they can see who I am and then prove to others that it's only one identity, right? So Sybil-resistance can leverage this identity information using these unique identifiers, social security number, passport number, all of these things are again, so you're trusting the government to maintain and keep those things perfect. So this has been working for the legacy system very well. But the idea here is how do we do the same without giving so much privacy? You trust the government, but you trust Google or you'll trust Facebook with your identity or your identifiers, your unique identifiers. The question is maybe yes, maybe no. Some people say no, I don't like the government, I like Facebook. Or maybe they don't like none of them and they just become no identity. So, and again, big challenge for decentralized identity. So the question here is, can we achieve Sybil resistance with privacy? So being able to have privacy and at the same time prove mathematically with cryptography and with certain systems in place or in design, architecture, infrastructure that can use cryptography to be able to maintain privacy and at the same time provide unique ability to provide an identity that's only yours. So this is a big challenge, and the biggest solution that we have, or one of the solutions that we have at the moment, is the novel privacy preserving Oracle. It's an Oracle protocol that's created by the students and faculty at IC3. So the next presentation, we will be going through that solution that addresses all these three different topics or challenges that we just mentioned. I hope you enjoyed the presentation, and let me know in the like the video and subscribe if you want, and let me know in the notes if you like it or not, and we'll see you in the next one. Take care.